All right. Hello, everyone. I hope you've been doing well. Today, I'm going to talk about lesson 10, which is power plant efficiency and power. This goes over the topics we talked about for lesson 8 and 9, which is about power plants in general and also the calculations for efficiency and power. So we're going to combine them together for one mastery assignment. All right. So let me read the objective. We're going to be able to describe the efficiency and power of a power plant qualitatively and quantitatively. So just by description or through mathematics. This is a review for efficiency. Efficiency is equal to the output work divided by the input work. And so basically it's basically the type of energy divided by the total energy in. So let's say we have like 5,000 energy in, but it was 3,000 kinetic energy, the efficiency would be like 0.6 or 60%. We can do this without numbers, just telling us what's the general efficiency will be. So let me give an example for that. So let's say we have a car moving in a smooth surface and a car moving in a rough surface. We put the same amount of energy for each surface. So let's say we put a large amount of energy for both of them, but it only moves a certain amount because of some different circumstances. So like for the smooth surface, it has a higher efficiency because it allows the kinetic energy was able to move freely with little friction. For the rough surface, there's more friction, so a lot of the energy just gets out, which decreases the efficiency. So as a summary, less friction on a smooth surface means the higher kinetic energy and less loss with friction. So that means there's a higher efficiency. We just compare the kinetic energy with the total energy we put. And we have a power plant. So this is a general example of a power plant where we burn a fuel to make a turbine. So we have a water pump and goes to a boiler. This is where we put the fuel, we burn the fuel, and this is where the steam comes out to go to a turbine, and it basically turns the turbine around to power a generator, and then the water just keeps on going down. The steam goes down and it's condensed, it's getting cooled to be water again. So it keeps on going over and over. Unfortunately, we can't just do this over and over again because of efficiency. We lose some energy on different parts of the system. So let's take a look at an example. Where we lose energy, let's talk about the walls of the boiler. When the water moves across the boiler, there'll be some friction. And also, some of the heat does not always go to the boiler. It also just escapes out of the power plant, so that's where we lose some energy. So that's why the efficiency can't be 100% in the boiler. For a turbine, it's just friction. A turbine is just moving blades around, and since it's doing friction against the air or sometimes even the turbine itself, we lose some energy there. And then the steam goes through some cooling water. So these are full of tubes. It'll experience some friction, which means there's some energy loss there too. So throughout the system, we have some energy loss. So usually it'll be around, if we're talking about natural gas or something, usually around like 70% efficient because we always lose some energy. Okay. So that was just a small review about efficiency in terms of thinking about it in a non-mathematical way. But now for the mastery assignment, it's going to be a little bit both of non-mathematical and also graphical and mathematical way. So you're going to complete this assignment that counts as mastery, so like a test grade, and it requires knowledge of lessons 8 through 10. So I'm going to go over that with you. Oops. So it's going to be another Google Drive assignment, and you should see this. So like I said, you need your knowledge from lessons 8 to 10 to complete this assignment, and it's going to give you a table and a graph. So I'm going to give you like several power plants. Here are the names, and I just abbreviated them right here in the code. And then what type of fuel they use. So natural gas, biomass, biogas, landfill gas. And then what was their total efficiency? So, and then I just graphed these just based on which power plant and then their efficiency. So these, the graphs and the graphs in the table show the same thing. So a lot of the questions is just basically analyzing the efficiency of each power plant, and then you're going to have to work backwards by having some numbers here and then using the efficiency and power calculations. And then number 4, it's talking about whether or not the power plants are sustainable or environmentally friendly, And then why do you think we still use these types of power plants for energy instead of renewable resources like solar and wind power? So all this is these 4 questions. It shouldn't take too long, so I hope you can get through it. Great. That's all for this video about power plant efficiency. As always, just let me know if you have any questions or concerns, and I'll be happy to help. Oh, and another thing, for if you've done lessons 8 and 9 practice, specifically lesson 9, I've also provided comments to help you have more guidance with the calculations to help you with this assignment. So that's all. Take care, everyone.